Wow, look at that. Absolute amateurs. I forgot to add us to the stream. Sorry, guys. I've only done this for the last 2 years. Welcome to February's ASV AstroTalk. This year, as you all know, is the 100th anniversary of the ASV, and we have a lot of things planned, including some quite amazing AstroTalks, and tonight's is one of our best, I'd say. Tonight we bring you Dr. Kirsten Banks, Wiradjuri, astrophysicist and science communicator, with her talk on 65,000 years of astronomy. But before we begin, I'd like to say that in the spirit of reconciliation, the Astronomical Society of Victoria acknowledges the traditional custodians of country throughout Australia and their connections to the sea, land and community, and we pay our respects to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islanders today. Tonight's stream is proudly sponsored by Optics Central, and remember, if you're enjoying tonight's stream on Facebook, you can throw some stars our way. And if you're enjoying it on YouTube, you can whack a sticker on there for us as well. All donations, no matter how large or small, are much appreciated. And if you're watching us for the first time, don't forget to subscribe on YouTube and follow us on Facebook. But first, before we begin our talk, I'll introduce our president, Mr. Chris Rudge.
Thank you, Mark. I was lucky enough to be working with Kirsten yesterday, at the when she was doing some filming at the Melbourne Observatory, and I have some very high hopes for this talk for us. So Kirsten Banks is a Wiradjuri astrophysicist and a science communicator. As she takes you through a journey that's been practiced in the land referred to as Australia for the past 65,000 years. Kirsten is a scienticia PhD candidate at the University of New South Wales, where she's studying galactic archaeology and astroseismology. Although she is also well known for her quick, entertaining science videos on TikTok. With no more ado, I would like to introduce you to Kirsten.
Thank you.
Thank you.
Hi everyone. I see some, somewhat familiar faces from this much in the audience today. Thank you so much for coming today. I'd like to first acknowledge the traditional custodians of the land that we're meeting on today, the Wiradjuri people. And of course extend that to any Indigenous peoples also here today. It's a privilege to have you in the room here. As a proud Wiradjuri woman myself, I'm very, very privileged to be on Wiradjuri country today. First of all, very flattered. I'm not actually a doctor yet. still doing the PhD, halfway through, got 2 more years left to go. But I will try to give you as much information as I can throughout this evening. What we're going to go through is basically 65,000 years in about 40 minutes. So I'll try to squeeze in as much as I can, but we're going to start from talking about a little bit of culture and the legacy that we have here in this country, in this land we now call Australia, with how much knowledge there is in astronomy, especially within culture. I want to start off by moving to the next slide, hopefully. Yes, I believe so. There's the laser pointer. If I'm pressing the right button, I don't know. It's the first in-person talk of 2022, so there's bound to be some technical issues. Thank you for sticking in. There we go. Okay. Was that you or was that me? I don't think that was me. There we go. Okay, point it at the computer. Maybe I should just press the button on the computer. I'm going to press the button on the computer. There we go. I can get my steps up and walk back and forth. Thank you very much. So let me introduce you Indigenous Australia. I hope many of you have seen this map before, and if you haven't, here it is. This is the Indigenous map of Australia. There are over 250 different language groups in Australia, all of which have their own unique view and perspective of the night sky, and such a rich history to use the stars as kind of like a canvas for our stories and the lessons that we learn from these stories. I mentioned that I come from Wiradjuri country. That's this big one right in the middle of New South Wales. Big country there. 3 different language groups and dialects within that country alone. So from more than 250 different nations, there could be up to maybe 500 or more language groups as well. Again, each with their rich history. But I want to take you on a journey now through the stars. This is a screenshot of a program that I love to use. It's called Stellarium. Anyone use Stellarium? Many of the people in the audience have used Stellarium before. It's a powerful program that allows you to see the night sky from anywhere in the world at any time. So this is the view from my old workplace, Sydney Observatory. A little bit in competition with Melbourne Observatory, of course. Very friendly, of course. But this is the view that we see from Sydney in a winter night sky. And I love the winter night sky because from our very unique position in the southern hemisphere, when we're in winter, Australia points straight towards the middle of the galaxy. It's the best night sky in the world, in my very biased opinion. But when we look at the night sky, we tend to see lots of patterns. Does anyone know any constellations? Again, I'm sure many audience do. But what we're going to do is I'm going to take you through a bit of a journey and I'm going to test your knowledge. So first of all, here are some of the constellations that I was talking about. These are our Western constellations, so from the Western view of astronomy and the night sky. But just to get a bit more acquainted, we're going to play a little bit of a game called Guess That Constellation. I'm probably going to guess that a lot of you may actually know what the constellations are, so we'll see how we go. But first constellation, I want you to guess, what is this middle constellation here? What does it look like? Any ideas in the audience?
It's a dead dog.
It's a dead dog. Well, it's certainly not the right way up, that's for sure. Any other guesses on what it might be? Canis Major. Yes, it is indeed Canis Major, the big dog. So one of the constellations in our night sky, in our current night sky as well, actually, with this big guy. The big bright star in the middle here is Sirius. And you could say it's seriously bright because it is the brightest star in the night sky and the best star in the night sky because there are so many puns you can make with the name of this star. So, good job. We got a dog for the first one. Now this second one is a little bit harder. So let's see how we go. What do we think this constellation is? Any guesses? A telescope? A telescope, it could be a telescope. Did I hear one up the back? The little dog. No one usually guesses it that fast. That's really good. Well done. It is indeed actually a dog also. I don't know if you can tell. It's a bit of a squished sausage dog with no feet, head, tail, or legs. But yes, it is Canis Minor, the little dog. So astronomy takes a lot of imagination, especially when it comes to these sorts of constellations. But I want to change your perspective for a moment to Indigenous astronomy and the different types of constellations we observe in our star lore. So I'll take you back to our blank night sky, remove any preconceptions you may have on the night sky, all those weird, wonderful constellations from Western astronomy, because here is what we see, some examples of what we see and observe in Aboriginal astronomy. The first one is actually very similar to constellations we see in the Western world. I'm sure many of us may recognize this constellation here. It's a very famous constellation, Orion. You've got his belt up there. Bit of a waste of space, only 3 stars. But it's a great constellation. In the northern hemisphere, we see him standing up tall, upright, with his club or holding with one of his hide of one of his recent kills. But he's the right way up in the northern hemisphere. And because we live on a globe Earth, when we come down to the southern hemisphere and we look at Orion from down under, he's kind of upside down. And being upside down is really interesting because in Wiradjuri astronomy, these stars actually make up a creator spirit constellation. the same stars make up another great man in our star lore. But what's really interesting about this is that it's the same orientation as Orion. This creator spirit is viewed as upside down. Let me show you a drawing by Scott Source Towney, a wonderful Wiradjuri man who designed this beautiful constellation artwork. He's upside down. You're still seeing him as upside down in our star lore, which seems, at surface level, a bit weird. You'd think that we'd look at him as the right way up, turned upside down, like from the northern hemisphere perspective. But the story of this creator spirit actually relates to how we see the perspective of him in the night sky. There's a story of this creator spirit chasing dinner one, which is what we call emu in Wiradjuri. And as he's chasing the dinner one, he trips over a log and falls face first into the ground. Bit of a humbling story for the creator spirit, but what's really cool and really interesting is that the way that these stars move in the night sky illustrate that story. So if you look later in the evening tonight, you'll see Orion, or you'll see this creator spirit setting in the night sky. You know how he sets in the night sky from this perspective? Head first. It matches and mirrors the story up in the night sky. What happens in the night sky is matched and mirrored on the ground. It's a very important concept in Aboriginal astronomy. So here we have our first type of constellation. Very similar, a collection of stars to create some sort of manifestation of an object, person, or thing. Now the second type of constellation I want to share with you starts to change our perspective of the night sky and give that new, different perspective. The next one, you may recognize these stars. Anyone recognize them? It's a bit hard to tell out of context sometimes, but we've got the Southern Cross on the right-hand side and the Southern Pointers on the left. So Alpha Centauri at the leftmost, and then Beta Centauri next to it. Now, in Wiradjuri and also Gamilaroi astronomy, we share some of our stories with our neighbours. The Southern Cross represents a tree, and these two pointers individually are birds. They're cockatoos. So each individual star here, an individual star represents an entire animal or entire thing within this story. And this is another great example of the night sky being the canvas of the stories. So another story is this tree, as part of this story, was taken up and uprooted and put into the sky to become the Southern Cross. But that tree was also the home to two cockatoos, these two birds. So as that tree was being uprooted into the sky, those two birds followed their home in the sky. And again, if you look outside and you see these stars, because these stars never set below the horizon from our perspective here in Melbourne, and also from a bit further north in Australia as well. So they're always up in the night sky for you to find, unless they're behind a tree or a building. These stars, they move through the night sky. The two cockatoos, the two birds, are following the tree. They always follow the tree as they move around in the night sky. So again, this story is illustrated with the stars. The stars are the canvas for our stories. Now the third constellation I want to share with you, which is my favorite type of constellation, because it completely changes our perspective even more so. Because so far we've seen that it's either a collection of stars, bright things, or individual stars, also bright things. But this next type of constellation is completely different. It is the dark constellations. So now we're looking at the negative spaces of the universe. Move left shoulder, please. There we go. Does that sound better for everyone? Hopefully online as well. Apologies for that sound issue. Back to our dark constellations. So dark constellations, instead of looking at the stars, we're looking at the dark spaces in between. So we've got this beautiful image taken by my colleague, Dr. Angel Lopez Sanchez, who works at Macquarie University and with Australian Optics. This is a great photo taken of the Milky Way from the Anglo-Australian Observatory. So you've got the AAT, or the Anglo-Australian Telescope, inside this big dome here. It's actually a telescope that I use for my own research. And it showcases the beautiful core of our galaxy. So another beautiful winter night sky view that we see here. And now, can anyone see an animal of some kind in this? Yeah, a couple of hands, The emu, absolutely. So this is my favorite constellation of all the constellations I've ever encountered. It is the emu in the sky. Now I know the pointer does actually have a laser pointer, which works, although it's disappeared. Okay, thank you very much. Okay, so I want to show you this beautiful constellation for those who can't yet see it, but once you see it, you can't unsee it. So let's go ahead. So over on the very right-hand side, you can see our familiar Southern Cross, our 4, 5 stars in the Southern Cross there. Below this is this really dark patch here, kind of like a beak sort of shape, and then the head just below it. That dark patch is a dark nebula, so a cloud of dust and gas in space that doesn't emit any light, so it's dark. It blocks the light from distant stars behind it. That is called the coal sack in Western astronomy. But that is the head of the emu, just below the Southern Cross there. Now continuing to the left, you have this long column right here. That's the neck of the emu, followed by this large bulge at the center of our Milky Way galaxy is the body of the emu. And there are some feet this way too, but I always find it a bit hard to find those ones sometimes. Okay, can everyone see it now? Right, once you see it, you can't unsee it. So one more time, just quickly, you've got the beak and the head, the long neck here, and big body there. In Wiradjuri, we call this Gulgomen, and Gulgomen is the sky emu. Dinawan is the ground emu, so they do have different names. And Gulgomen, its position in the night sky tells us a lot about what's happening on the ground. So this emu, when it's rising in the east, just after the sun has gone down, it kind of looks like an emu running along the horizon. So this indicates to us at this time that the emu are now running around looking for a mate. But later in the year, when the emu, the body of the emu, this Milky Way galaxy has moved higher and higher up in the sky as the Earth moves further around in its orbit, we now see that perspective change from our Wiradjuri perspective to an emu egg in a nest. And that indicates to us that now is the time to go looking for emu eggs. So the night sky not only is a canvas for our stories, it's also a seasonal menu of sorts, as well as a seasonal calendar. The night sky, different stars in the night sky can tell us when certain seasons are beginning. We can even predict the weather with the stars. There are some stories and some knowledge from around the Torres Strait that talk about the severity of the twinkliness of stars. And if it's really severe, then storms are coming, because you've got a really turbulent and wobbly atmosphere. And that knowledge has lived and lasted, despite all odds, for tens of thousands of years. It is quite a rich history that we are privileged to be a part of in this land. And to build on the shoulders of giants, we begin to go through the journey of doing science today with Indigenous elders as well. I'd like to shamelessly plug a book written by a good friend and colleague of mine, Dr. Dwayne Hamaka. He has just written a book and it's being published very, very shortly called The First Astronomers, co-written with many elders as well around the country, and will be a great read. So if you want to learn more about Aboriginal astronomy from elders, facilitated by Dr. Dwayne Hamaka, please go ahead and read it and buy it and love it, because I know you will. Continuing on though, we have this big telescope here. We've had advances in astronomy over the years for the past couple hundred centuries, that's the word I'm looking for. And with each new discovery comes more answers and even more questions and more space to explore. So I want to come more into the present very shortly. But at first I want to show you a couple of stars that have actually gotten global recognition from their Aboriginal origins. So this star is actually a star known by Unurgunite. So its designation is Sigma Canis Majoris, so you may recognize this constellation from earlier. But this star here that's highlighted is traditionally known as Unurgunite in Wurren astronomy. And the Wurren are from northwest of here, near Lake Tyrrell. So the Wurren people see this star and call it Unurgunite. And the story of Unurgunite is very, very interesting. I quite like this story because, again, it illustrates the story in the sky with how the stars and planets also move around. So Unurgunite has two wives. They're his two stars either side of the star. So Unurgunite and his two wives up there. But the moon, known as Mitian in the story, represented by a spotted quoll, fell in love with one of the wives and tried to lure her away. And when Unurgunite found out about Mitian's trickery, they had a great battle. Mitian lost that battle and was left to wander the skies for the rest of time with the battle scars visible on his face. I see some heads nodding here. You know exactly what those battle scars are. When you look at the moon, what do you see? You see craters, you see the mare, the seas, those dark patches, either a man or a bunny on the moon, whichever way you look at it, right? You see these features that are represented by the battle scars of that great fight. And if you think that is cool, building on top of that, the act of Mitian trying to lure away one of the wives is illustrated in the sky. There's this thing called an occultation. Who's heard of that before? A couple. Okay, great. So an occultation occurs when you have one object passing it. Wait, hold on. We have one object passing in front of a second object, blocking the light from the second object. Okay, this happens quite a lot with stars and the moon. So when Mitian, the moon, is luring away one of the wives, it covers one of the wives. It does an occultation with one of the wives. Only one of them. But then when they have their great battle, what do you think happens? The moon does an occultation with Unurgunite, the star. So again, our stories are illustrated in the canvas of the sky. So that is star number one. Star number two that has its name globally recognized by the International Astronomical Union is this guy, Zeta Phoenicis. I think that's how you say it, but Wurren is its traditional Wardaman name from the Northern Territory. And Wurren means child in Wardaman language. And this star is an example of a seasonal calendar star. When this star is high up in the northern sky, that indicates that the monsoon season is about to begin. So we have that calendar, that seasonal calendar representation there. The third star is a very notable star from the Scorpii constellation up in the winter night sky, where you've got that Milky Way going straight across there. This is another Wardaman star name, Larawag, designated as Epsilon Scorpii, but we've got Larawag as its traditional name, recognized worldwide. Now, all of these stars in the body of the Scorpion represent a different stage in a ceremony in Wardaman culture. And Larawag is known as the signal watcher. So he gives the all clear signal to move on to the next stage of ceremony. And now the fourth one I want to share with you tonight, which is my favorite of all four, because it's a pretty recognizable star for many reasons. It's this one. The star is on our flag. It's on bumper stickers. It's tattooed on some Australians. Right? This star is officially recognized worldwide by its traditional Wardaman name. So again, from the Northern Territory, the Wardaman people call this star Ginan. And the story of Ginan is really beautiful. Ginan represents a small red dilly bag, that's just a bag, that's full of songs of knowledge that are passed on from generation to generation. And I think that's a beautiful indictment of what we're doing tonight and what we do in everyday lives. We learn from our elders. We learn from the knowledge, whether they be songs of knowledge or just knowledge in general, and we pass that on. And that is on our flag. It's everywhere. And it's beautiful that it is recognized by its traditional Wardaman name. But, well not but, and building on that, I'd like to bring you back to a bit more of the present and start to share with you a little bit about what my PhD is and what I'm doing to build on top of this knowledge that we are so privileged to have here in this nation. So I use this big telescope inside this big dome here, but the research that I do and that every scientist does wouldn't be possible without the science that was done beforehand. We're constantly building on what we know. And a few hundred years ago, not very long ago, space was a lot smaller than it is today, from what we know. Anyone know who this lady is? Yes, Henrietta Swan Leavitt. She was one of the Harvard computers. So at Harvard Observatory in the early 1900s, she came back to the Harvard Observatory to be a computer. So women were employed at observatories, much like at Melbourne Observatory here as well. If you had a chance to go through the exhibit at the telescope, there's a beautiful little exhibit on the Harvard computers who worked at Melbourne Observatory. But these women, they did the real science, in my opinion. They looked at photographic plates of stars taken by the big telescopes and actually catalogued all of the stars, noting down their brightness, where they were, their positions in the night sky, and even cataloguing their spectral type, so what sort of type of stars they were as well. And Henrietta Swan Leavitt, she noticed that a specific type of star called a Cepheid variable star had a particular behavior. So variable stars, they, much like the name suggests, they vary. And these particular stars, they vary in brightness in a certain way. So they go from their brightest to their least brightest and back up to their brightest again over certain periods. And Henrietta noticed that the period at which these stars oscillate between their brightest and their least brightest was related to their overall brightness. And this is what led to the first ever standard candle. And she actually coined that term, which is very cool to learn that recently. So a standard candle is kind of like a cosmic street light. All the street lights are the same, so you know what the brightness is. And when you know what the brightness is of a certain star, and you record how bright it appears through your telescope, you can then work out the distance to those stars. And so Henrietta found that these Cepheid variable stars were a great standard candle to help us measure very accurate distances throughout our galaxy and beyond. And it was from her work that another astronomer known as Hubble, you may know him based on the telescope, the Hubble Space Telescope, named after him. Hubble then used this Cepheid variable star standard candle to measure the distance to this galaxy. All right, let's test the knowledge. What galaxy is it? It is Andromeda. Yes, our nearest, biggest neighbor. Beforehand, Andromeda was observed before. We knew about it because you could see it. You can see it with the naked eye in the northern hemisphere in a place with very little light pollution, and very easily with a telescope as well. But originally, it was thought to be within our own galaxy. It was known as the Andromeda Nebula first, just a smudge in the sky. But when Hubble used Cepheid variable stars and used Henrietta's work and knowledge to measure the distance to Andromeda, he realized that it was actually around 2.5 million light years away. A bit far out of the galaxy, because the galaxy isn't quite that big. And with that discovery, we realized, oh crap, we are not the only galaxy in this universe. We are not the only star, we're not the only planet. Are we not the only life? We don't know yet. Maybe we'll answer that in a few years' time. But it really opened our eyes to just how big the universe was, or is, rather. It's really, really big, right? Before that, we could only really measure distances accurately to a few hundred light years, maybe a few more, maybe a few thousand, using parallax. So when you look at a star from one side of the sun in orbit in the Earth, a star will appear in a certain position based on the stars that are far, far away behind it. But 6 months later, you come over here to the other side of the sun, and that star will appear in a different position relative to the stars behind it. Is everyone catching on? Try this as well, because I want you to see this properly. Put your finger out in front of you. Close one eye. See, note down its position relative to me. Now open and close the other eye. Did your finger move relative to me? That's parallax. It's the same concept, that when we move around the solar system, we can measure the distance to stars in that way. But that's very accurate to not very far. And by not very far, I mean a few hundred light years, which is far, but not very far for me. Okay, but when we did this with the Cepheid variable stars, we expanded our horizons from a few hundred light years to 20 million. It's really far. All right, and we've continued to build on that knowledge to see even further. A few other standard candles include exploding stars. Certain types of exploding stars, but exploding stars nonetheless. And that has expanded us to understand that our universe is really big, again. More than 94 billion, billion? 94 billion light years across. It also helped us realize that the universe is expanding and getting even bigger every second that goes by, which is a terrifying thought sometimes. But it's things like this that have helped us open our eyes to what is out there and how big our universe is. Now, the reason why I mention all of this is because I too use a standard candle in my research. This is an example of one of my standard candles. This is called a red clump star. I'll explain why we call it a red clump star in a moment. You're going to laugh because we're just really bad at naming things in astronomy. But red clump stars are these types of evolved stars, not quite like our sun. Our sun is happily burning hydrogen in its core and turning it into helium. These stars have burnt through all of their hydrogen in their cores and are filled with helium now, and now they're burning helium. And these stars are very known to be the same brightness. And we can use them to accurately measure distances and accurately map the galaxy. And that's what I'm trying to do in my research, with a few caveats. There's quite a plot twist here and there within my research. But there are other ways to measure distances, so parallax again. This spacecraft right here is called the Gaia spacecraft. It can accurately find the distance to stars within this little circle here. Beyond that, it gets a bit more uncertain. Beyond those, about 3,000 light years away. 3,000 light years? No. Yes? Maybe. Far. Not too far. Just a little bubble. Okay, but with red clump stars, we can measure about this far quite accurately. At least more accurately than that Gaia spacecraft. But there's a problem. First of all, this is the red clump. This is the red part of the spectrum on the very right-hand side. And that's a clump, and it's in the red, so it's the red clump. I told you, we're good at naming things. But there's a problem. Red clump stars are very similar to another type of evolved star called a red giant branch star. Can you maybe point out where the red giant branch might be? A big branch-looking thing in the red? Yeah, that's it. So these red clump stars overlap the red giant branch. The problem with red giant branch stars is that they are not standard candles. They're not burning helium in their cores. They have what we call an inert helium core. So just all this helium hanging out, not doing much. So they overlap. This makes them look very similar. Now, I'll be honest here, this is actually the same photo, just flipped upside down. But just imagine one's a red clump, one's a red giant branch, okay? Okay, so the red clump and the red giant branch, they look very similar. So we have a problem here. We have this very good standard candle that we can use to accurately map the galaxy, but what if this is actually a red giant branch star and we just don't know it? We need to somehow find a way to distinguish these stars effectively. And we can do that with a little thing called astroseismology. Now, the reason why I have some beer bottles up here is because I have some bottles here as well. Imagine these are stars. We have our almost identical stars. They look exactly the same on the outside. Astroseismology can help us to distinguish between these two stars, or these two bottles, by analyzing the frequency at which these stars oscillate. So astroseismology, much like seismology, is about studying quakes on stars. So sort of earthquakes, star quakes, if you will. So when we observe these stars, we can see these oscillations, and we can distinguish between the two. Okay. Why? Let's see why. We have these two identical stars. If I were to oscillate one of them by blowing into them, let's see what happens. Okay, we'll do this one first. Makes a nice little tune. What about this one? Looks exactly the same. Should it sound the same? Maybe. Let's find out. All right, it didn't quite sound the same. Anyone know why it didn't sound the same? The volume of water, yeah. So I've been conveniently covering up how much water's in it. So this one's got more water in it, this one's got less, which means that they'll oscillate at different frequencies. That is what's going on with these red clump and red giant branch stars. They look the same on the outside, but what's on the inside is different. One is burning helium, one is not. One is a standard candle, one is not. We don't like it, get rid of it. So we need to find out a way, so we now have a way, rather, to distinguish these two stars. There's another plot twist. Astroseismology is a long person's game. Astroseismology, in order to see these oscillations happen on the order of days. So we need to stare at a star for days at a time, weeks at a time, sometimes even years at a time. I only have 4 years to do this PhD thing. That's not going to work for me. So my research is about looking at the spectrum of stars. This is an example of one of the stars that I'm looking at, actually, just a little snippet of it. So when we look at the light from a star, we see it's not all uniform, it's not all bright. There are some parts of this spectrum that have gaps in it. And these gaps tell us what the stars are made of. So each line here, we call it a spectral line or a spectral feature, will tell us what the star is made of and how much of that stuff is in there. So a few examples, this really fat line here, that's the H-alpha line. It tells us that there's lots of hydrogen in those stars. That's good, we expect that. Stars are mostly made of hydrogen. Good. This line over here is a carbon line, so it tells us that this star has some carbon in it. Not unheard of, there's a lot of carbon out there in the universe. And this guy here is an iron line. So there's some iron in there too. Now these features, we think, it has been demonstrated before that some of these features do actually map to what the astroseismology tells us about these stars. And the great thing about this method is that when I look at a star, at most, I'm staring at it for about an hour, just for one star. The maximum amount of stars I've gotten in one night, when it was perfectly clear, no clouds, best night ever, 20 stars in one night. Not a huge amount, but still a lot faster than astroseismology. So my research is about trying to find this kind of blueprint to distinguish the red clump, the good ones we want to use to actually map the galaxy, from the red giant branch. Once we have that, once we have this nice clean, effective sample of red clump stars, we can start mapping the galaxy. We can then use this information again to find out what they're made of. And from this, we can also work out how old these stars are, also from their mass. And that is where the galactic archaeology comes in. You may remember that term from the little introduction at the start. So my PhD is galactic archaeology, a bit of astroseismology. All things would happen in the ground, but we're just doing them up there. So the stars act as like fossils, a bit of a fossil record. So if we know what these stars are made of, and how old they are, and where they were born in the galaxy, we can rewind time to work out what the galaxy was like at the time and place of the birth of these stars, and start to piece together the puzzle pieces of the 13.1 billion year long history of our galaxy. Yeah, I'm trying to do that. That's about it. So that is what I'm up to. In the future, I'm really excited to see what we might find with the James Webb Space Telescope. It finally got out there, thank goodness. Without any failures, touch wood, it still has a bit of a while to go. But we can, with the James Webb Space Telescope, we can see this, but more. The James Webb Space Telescope, this gorgeous looking thing, will be able to unfold the universe to depths we've never seen it before. hopefully see the first stars, see some pretty awesome space photos, but it will change that to this. This photo actually was taken by the Hubble Space Telescope, but it'll open up more. But this is an infrared version of this image here. So optical, infrared. How much more information and stuff is there to see and analyze in that infrared image? We can open our eyes to lots of different wavelengths to find out more about what is out there in our universe, how our universe came to be, if there's life out there. That's one of the things that James Webb will also be looking for. And I am really looking forward to seeing that first image coming from James Webb in 4 months' time, 3 to 4 months' time, June, July. But that's the future, and who knows where we'll go from there. And that is 65,000 years of astronomy squished into about 40 to 50 minutes. Thank you all so much.
You don't have to applaud me. It's okay. Do we have any questions for Kirsten? I think you've stunned them all so far.
Yes.
No? No one? Scanning the room. Oh, there's one down there. I'll come and bring the mic and you can embarrass yourself on YouTube and Facebook.
Hi, Kirsten.
Hello.
What's your favourite, the how or the why?
Why is hard to answer. Why is very, very hard to answer. Like, why did the universe start? I don't know. How? We kind of have an idea. Maybe. Maybe not. But yeah. I'm going to have a cop-out answer for you and say all of the above. Because all of it is so, so interesting, because when we answer a question, we then get like 10 more questions, which means I will be always employed. Thank goodness. Job security.
You've still got job security here. We have a couple more questions.
Excellent.
They're all getting. They're not nervous anymore.
Good.
Not until I tell them there's 1,000 people watching online.
Ooh.
Just a brilliant presentation.
Thank you.
Yeah, and I think the emu looks better when you see it rotate around standing up.
Yeah, it is
You
so
know what
beautiful.
I mean? Yeah, that looks brilliant, doesn't it? Yeah.
Totally
Thanks.
agree. Totally agree.
I'll pass it over to this young man.
Hey, I'm really looking forward to the first Australian you mentioned, the first astronomers, sorry, the book. Is there any other kind of Indigenous astronomy, like literature or resources you can recommend?
I would recommend going to the website aboriginalaastronomy.com.au. All the resources that are reputable are there. Yeah.
I'm going over here now.
Great talk. What made you choose Asteroseismology and galactic archaeology? They're awesome names.
So my honours research, I promise this is relevant, my honours research was in the merging of galaxies. So huge galaxies just crashing into each other. I gave the tagline of my honours thesis, A Tale of Galactic Cannibalism, because it's just galaxies eating each other. My supervisor crossed that out as soon as I put it in. Damn it. But usually when you go into a PhD, you tend to continue in your field of whatever you did in honours. I did not, because I decided to take an opportunity where my honours coordinator came up to me and was like, oh, Kirsten, there's this really good, what's it called? Not stipend, scholarship that we think you would be really great in. And with this particular scholarship, the topics are already pre-chosen, and then you express an interest in that topic. And the topic that I wanted to do, this astroseismology and galactic archaeology, the supervisor was honestly one of my biggest decisions, because my supervisor, Sarah Martel, she is an amazing woman, a great researcher, and just all-round great gal. So that's how I got into that field of research, and I now love it.
We have another question. I'll come back to you, Barry, if you behave.
Thanks. Is there any consistent variation from the east coast to the west coast in their legends for the star constellations?
I love that you asked this question, because I have a bit of an analogy for you to explain that. So Imagine you're back in high school and you have some juicy gossip. You tell your juicy gossip to the person next to you, and as it continues down the line, some of the details get lost. Once it gets to the other side of the classroom, the story has completely changed. So from that, neighbours have very similar stories, similar areas, similar environment, but on the other side of the country, it could be different. It may be similar on different stories. So there's one story that goes across the nation and across the world, to be honest. That's the Seven Sisters songline. Seven Sisters you would know in Greek mythology as the Pleiades. But the Seven Sisters, as far as I'm aware, is everywhere. It's incredible. It's one of those things that we have all seen and then taken a very similar story from. But yeah, so there's some differences here and there as well.
I think we've got any more questions. Barry, do you have a question? I'm gonna get some others to ask some questions. You're right about the Seven Sisters, your Subaru. It's the same in so many, even in native Indian culture as well. They see the same
really?
thing. Yeah.
It's incredible.
Hi, I'm not sure if you can answer this question, but in your talk you talked about how in Aboriginal culture the stars can align with sort of being able to predict weather and things that are happening on the ground. Mm-hmm. With climate change in the last 40, 50 years, with changing weather patterns and big changes in our environment, are there any changes in the stories that the elders have started talking about, or things out of sync that they're talking about at all?
Not that I'm aware of, but great question. I hope that there is an answer for that someday for you.
I think we have one more question before we go to our tour of the night sky.
This is not a question. This is I talk about Henrietta Swan Leavitt. I've made a presentation a while years ago on famous women astronomers, and there's an article in two Cruxes back in 2017 on this, and Caroline Herschel and Wilhelmina Fleming didn't receive Nobel Prize because that was too early. They only started receiving Nobel Prizes in 1900. But no woman has received a Nobel Prize since then. Although Henrietta Swan Leavitt, she passed away unfortunately, and a few months later they recommended she got a Nobel Prize, but she didn't.
Yeah,
and even the modern ones like
yeah.
Jocelyn Bell should have got a Nobel Prize, but did she get one? No,
nope.
because she's a woman.
Mm-hmm. And the story with Jocelyn Bell is quite scandalous as well. Like, she discovered, what was it that she discovered again? It was Jocelyn Bell? Oh, pulsars. Yeah, pulsars. So she discovered pulsars, this whole different type of star that we'd never seen before. But then her supervisor at the time didn't think anything of it until a few years later he's like, oh, yeah, this is actually this, and then published a paper on it. Mm-hmm. And then won the Nobel Prize. But Jocelyn is a great lady, and she actually agreed that she shouldn't have won the Nobel Prize anyway because she was a student. So what a humble woman.
Very humble.
She is, yeah.
Now, Tasmania wants to know if you can go down there and give a talk.
Yes, please.
We've
I
had
haven't been before. I would love to go.
We have people watching from everywhere, so. Chris, would you like to come up and say a few words?
Thank you. Thank you so much.
Thank you.
That was a fabulous talk. I thoroughly enjoyed it, and I loved finding out about the Aboriginal astronomy, something that I have missed out on and thoroughly enjoyed. I will certainly research it some more. Thank you so much.
Thank you. Thank you all for being here. Thank you so much.